Welcome to repeated roots in practice. So recall if equation A y double prime plus by prime plus cy equals 0 has characteristic equation AR squared plus BR plus C equals 0 with repeated root R1 equals R2 equals alpha. Then y1 equals e to the alpha t, and y2 equals t e to the alpha t. Form a fundamental set of solutions. For the equation. So let's go ahead and put this into practice. For example, let's find the general solution to y double prime plus 8y prime plus 16y equals 0. So the first thing we need to do is find the characteristic equation. Which in this case is r squared plus 8r plus 16 equals 0. This left-hand side factors as r plus 4 squared equals 0. So we get r is -4 is our repeated root. So we have r1 equals r2 equals -4. Therefore, we get the solutions, or a fundamental set of solutions. Are y1 equals e to the -4t, and y2 equals t e to the -4t. From this, we get our general solution. Y equals c1 e to the -4t plus c2 times t e to the -4t. Alternatively, you may see this written as y equals e to the -4t times c1 plus c2t. Next up, let's go ahead and solve an IVP. Let's look at the equation y double prime minus 4y prime plus 4y equals 0. With initial conditions, y of 0 equals -2 and y prime of 0 equals 1. So the first thing we want to do is find the general solution. So we will do our characteristic equation. Which is r squared minus 4r plus 4 equals 0. This left-hand side is r minus 2 squared, that's equal to 0. So we get r1 and r2 are the same, and they are our repeated root 2. We therefore have a fundamental set of solutions. Y1 equal to e to the 2t, and y2 equal to t e to the 2t. And general solution y equals c1 e to the 2t plus c2 times t e to the 2t. Next step, we need to plug in our initial conditions. So for our initial conditions, we were told that y of 0 was -2 and y prime of 0 equals 1. So y of 0 is -2, y prime of 0 equals 1. We know that y is c1 e to the 2t plus c2t e to the 2t. That means that y prime is 2 times c1 e to the 2t plus c2 e to the 2t plus 2c2 times t e to the 2t. If we set y of 0 equal to -2, we have y of 0 is c1 times e to the 0th plus c2 times 0 times e to the 0th. The second term just goes to 0, and so we get, we know this is equal to -2. We wind up just getting c1 equals -2. Y prime of 0, we are looking at 2 times c1 times e to the 0th plus c2 times e to the 0th plus 2 times c2 times 0 times e to the 0th, and this is all equal to 1. That last term, once again, just goes to 0. We know c1, so we can plug it in. I'm going to simplify first, though. So we have 2 times c1 plus c2 is equal to 1. c1 is -2, and so we're looking at 2 times -2 plus c2 equals 1. That winds up giving us that c2 must be equal to 5. And so our final solution would be y is equal to c1 -2 times e to the 2t plus c2, or 5, times t e to the 2t. So again, this is how we can go about finding the general solution, as well as finding solution to an IVP if we have a repeated root for our characteristic equation.